Hello everyone, my name is Murtaza Hassan and I am currently in the final year of Metallurgical and Materials Engineering. From the very beginning, I was very passionate in teaching chemistry, especially organic chemistry. And as per my domain is concerned, I belong to the material science, which drew me in this because there is a very strong bond between material science and chemistry, which of course drew me in this field. So today we will be discussing an important topic of organic chemistry, where we will be discussing reaction of enolates with carbonyl compounds. Okay, so in this lecture only we will be discussing the reaction of enolates with carbonyl compounds and the very famous, of course, a very famous reaction Aldol condensation. Okay, starting with the basics. So we have to see where from these enolates came and how how they react in the organic chemistry. Okay, let me add the page. So let's take a simple example of acetaldehyde, CH3, single bond, C double bond, O with H. Okay. So this is the acetaldehyde. Arithna, IUPAC name. Okay, this is it. Now acetaldehyde. I am treating this compound with the base NaOH. So this is base NaOH. And which of course that will give the hydroxide ion which will react. And if we see that why this OH negative will attack, so there are two possibilities. If we see there is an electrophilic carbon because we know the electron density will be shifted towards the oxygen because of more electronegativity, and we can see there will be a vacant pi star orbital which I think we should know on the carbon atom. And so because of this vacant pi star orbital, this hydroxide ion can react with the electrophilic carbon over here. So there is some another possibility that this hydroxide ion can react with one of the acidic hydrogens. Because if we see this is C double bond O, and adjacent to that is the alpha carbon, and these hydrogen atoms attached to this carbon are referred as alpha hydrogens. Okay. So if we see there are three alpha hydrogens and we are having the electrophilic carbon. Okay. So we have to see where to attack. Okay. So if we see the nature of hydroxide ion, if we see this is more nucleophilic rather than basic. What that means? It means this OH negative has tendency to react more with this carbon, electrophilic carbon, rather than this acidic hydrogen. But if we see the reaction, there will be some we can get the minimum concentration of like this. This will react with the acidic hydrogen and will get that minimum concentration. So we're having acidic hydrogen here, and we're interested only with, will keep this carbonyl group aside, or we're only interested with the acidic hydrogen. So this base will come, OH negative will come, and this will react with the acidic hydrogen, and we'll get the water molecule out from here, and we'll get CH2 negative single bond C double bond O with H. Okay, and if we see the resonating structure of this compound, this will be the resonating structure of this compound. CH2 double bond C single bond O negative H, and this thing is called the enolate ion. And in Aldol condensation, we have to only look like, is there alpha hydrogen present? Yes, sir, there is alpha hydrogen. If there is alpha hydrogen, so there is a possibility that enolate ion will get formed and which will react with the other, because we have taken this acetaldehyde in maximum quantity and we got this enolate ion, and there will be some unreacted part of like unreacted amount of acetaldehyde where this enolate ion has to react. Okay, let's see. So we are having the excess CH3 acetaldehyde, which is unreacted acetaldehyde H, and this enolate ion will come. Now there is a possibility. So there is an electrophilic carbon. This is the electrophilic carbon which is having the vacant pi star orbital, and this enolate ion will come and react with this. Now you will think, sir, will this oxygen which is having the negative charge will react with this carbon atom, or this carbon will react with this electrophilic carbon? If we see, this is again a resonating structure of this. If we take this resonating structure, Ca2 negative, C double bond O, this carbon having negative charge is more nucleophilic rather than oxygen having negative charge. Because oxygen is more electronegative, and it will of course stabilize the negative charge of oxygen, and it will reduce the quantity, which will reduce the nucleophilicity of this oxygen. So this carbon atom having the negative charge will react with the electrophilic carbon atom over here, and this electron density will get shifted towards this oxygen atom. So what we are getting over here is CH3, C single bond O negative, and this is H, and this carbon has reacted with the carbon, this carbon CH, 2 single bond C, double bond O. Okay. So if we see, so what is the benefit of this reaction? What is the benefit of this reaction? If we see, we have made a compound which is having the CC, we have gained the one CC bond. Okay, if I highlight this bond over here with another color, so this is the new carbon-carbon bond formed. Okay, so now this thing we react with the, of course the reaction will be having in the container where doing this reaction, there will be some amount of water. So this will react with the water over here, water molecule. So if we make the structure of water molecule by having HO, this will deprotonate the water from here and will take H positive from this and it will get back OH negative. So which was the this our catalyst anyway. So of course it acts as a catalyst because we got it back. So we got hydroxide ion back and we got the compound as, let me erase this thing. So we got CH3, COH, H, CH2, C double one O. So we got this thing. And this thing is called aldol. What? This thing is called aldol. This is called aldol. Now we have to see what will happen after this. Okay, so now we're using the base as a catalyst. Again, let's see again what will happen. Let me erase this. Okay. So this was it. So again, I'm treating this as base NaOH. So there is the hydroxide ion. Again, will come. And if we see OH is a very bad leaving group, it will not. It's very bad leaving. Okay, if we see there is again a most acidic hydrogen over here, so this is CH2, and if I write it as CH and H over here, and this will again react with the most acidic hydrogen. This is the most acidic hydrogen, and once it will react with the most acidic hydrogen, again we'll get the water molecule out from here, and there will be a negative charge on this carbon atom. Okay, let me erase this thing now. Okay, so we'll get the negative charge on this carbon atom. If you see this reaction, you have seen during the reaction mechanism, we have a particular type of reaction which is called E1CB. E1CB conjugate. This is a type of elimination reaction where the carbon atom having negative charge is connected with other electron withdrawing group. So this is the electron withdrawing group which will stabilize this negative charge. Okay, but once this stabilizes this negative charge because of the element, so this will go out. This will go here and we'll get OH out from this molecule, and we'll get the alpha beta unsaturated compound. If we see, which will be CH3, CH, double bond, CH, single bond, C double bond, O with H. So this will be the alpha beta unsaturated compound, and this is the aldol. This was the basic reaction of aldol condensation. Now let's discuss some more advanced problem on this aldol condensation when we see the complications that will come in this reactions. Okay, let me discuss some new problem on this topic. Okay, let's see. So I am having the one important thing we can do is we can let's take the example. Let's I have electron. So this is the structure of electron. This is the structure of electron. So here we can see we have blocked one side of the carbonyl compound. So there was the carbon atom. We have removed that carbon atom. We have oxygen atom here, and there is no alpha hydrogen in this. So this is the oxygen. There is no alpha hydrogen. So there is only one carbon atom which is having the alpha hydrogen. So we have blocked one side of the carbonyl compound. So if you want to make a particular group where you don't want things to get messed up, you can block one side of the carbonyl compound. Like I have some other compound I can take. Like I am having this thing, C double bond O with H. So again, CH3. If we see again on this carbon atom, there is no alpha hydrogen. We are having this carbon only which is having alpha hydrogen, and you can only play with that alpha hydrogen, and you will get the product whatever you want. Okay. So let's take some more this advanced example of this aldol condensation. So if I am having So this is our carbonyl compound. So this is our carbonyl compound, and we have treated it with enolates. This is the base. Okay. This reaction is called intramolecular aldol condensation, where we are having both the carbonyl compound in a single compound. Okay. If we see, we have three choices here. We are having one alpha hydrogen here, we are having another alpha hydrogen here, and we are having another alpha hydrogen here. So you have to choose which one alpha hydrogen I have to choose. Let's see this alpha hydrogen. If I'll react the base with this alpha hydrogen, if this will provide this depropionate this acidic hydrogen, there will be a negative charge on this carbon atom. And if this negative charge will come on this carbon atom, this will then attack on this carbon atom. But the completion in this reaction will get 1, 2, 3, 4, 5, 6, 7 membered ring, which is not proper. Okay, it is having maximum instability because of structure and spring. Okay, so we can see we can't choose this alpha hydrogen. So now we have two choices. Either we have to choose HB or we have to choose HC. Okay, so let's see now which one. So there are two possibilities. If we are concerned with the stability of the product, that is called a TCP, thermodynamically controlled product, where we see the stability of enolate ion which is getting formed. Okay, so this is the acidic hydrogen. If let's suppose base will come and react with this acidic hydrogen right here. So this will depropionate this acidic hydrogen from here. So there will be a negative charge on this carbon atom, and one of the negative charge will be on this carbon atom. This will be in resonance. We will be in resonance with this C double bond O, and this will be like this. This will be the resonating structure. If I try to make it like this, so this would be its resonating structure, CH3, and so on like this. So this will be if I will react with, if I will depropionate this acidic hydrogen. Okay. Now I have another choice, SC. If I react base with this acidic hydrogen, what will be the product? Okay, let's see what will be the product. This HC will go out from here. There will be a negative charge here, and this negative charge will be in resonance with this C double bond O, and this negative charge will come here, and here will get H O negative double bond and this thing. Okay. Now look at these two things. We are having the enolate ion 1 and enolate ion 2. If we see the stability of enolate ion 2, so because of the hyperconjugation structures, if we see the alpha hydrogen over here, there are 3 alpha hydrogen, and from the other carbon atom there will be more 2 alpha hydrogen. So we are having 5 alpha hydrogen, which will stuck by this enolate ion because of the hyperconjugation, and thermodynamically it will be more stable. And if we see this thing, there will be only 2 alpha hydrogens which will stabilize it. It will stabilize it, but according to like here we are having 5 alpha hydrogens, more hyperconjugation structure meaning more stability. So it will react with this will react with this carbonyl compound only. So there will be a negative charge on this, and this will be in resonance with this carbon atom, and again the negative charge will get shifted back to this carbon atom. Negative charge will come over here, and this negative charge will then attack on this carbonyl compound. So we'll get a 5-membered ring over here. So if I try to make this 1, 2, 3, 4, and 5-membered ring, so this will be like this. So this will be C double bond O, CH3, and here will be O negative. And similarly, you can then use again a water molecule. This will depropionate the water molecule. With the shortage of time, I can't discuss this further. So there are some further steps which I have already taught you. So this was all about Aldol condensation. Thanks.